Okay, let us today start with our problem number 52. Again, based on it is from the advanced paper of this year. Topics involved are gravitation, rotatory motion, and center of mass is also involved. That will be as part of the step you will get. You will have to consider center of mass also. It is what is described here is a binary star system where two stars are moving in circular orbits due to mutual gravitational force. You can see in this diagram, one star is of larger mass m, and the other one is smaller mass m, and moving about their center of mass. Center of mass will be the center of rotation. Center of mass distance for the larger mass is x bar marked here. The other star will be r minus x bar, where r is the distance between the two stars, between the centers. So one star is moving with r minus x bar radius, the other is moving with x bar radius about the center of mass G, marked as G. So in this process, center of mass will be nearer to the larger mass, and also in the process, if one star moves, as suppose this star is coming to this position, other star will be in its own orbit in the same straight line with the center of mass. So suppose this being the center of mass, the other star will be making the same straight line, and it will be here. So that always center of mass and the two stars will be in the same straight line. This in this process, the distance between the stars will change. Center of mass also will change. So you can assume for a small angular displacement, center of mass you can take it as the same, but the instantaneous position will be making same straight line with the center of mass. That is the case. Here the radius changes, that is clear from the requirement of the question itself. 1 by r dr by dt is the rate of change of r. Relative means you divide by the present instantaneous radius, you get the relative rate of change of radius. So that is what we want to find. Here two formulas we are going to use in the solution. Formulas are described here. One is the moment of inertia about perpendicular axis through the center of mass for a two particle system. Stars, maybe you can consider it as two stars, means capital M and small m. So about the center of mass, we have to take them as point masses because this type of questions. Center of mass axis, perpendicular axis to the center of mass, moment of inertia is given by I is equal to mu r square, where mu is the reduced mass. Product of the masses upon sum of the masses, that is mu, into r square. R is the instantaneous separation between the stars. So that will give you the instantaneous moment of inertia about the center of mass perpendicular axis. That we are going to use in our solution. Second, the formula is distance of center of mass from one of the stars. I am taking the larger star. Distance of center of mass from the larger star is x bar is given by small m by m plus m into r being the instantaneous separation. This is because m1 x1 equal to m2 x2 for the center of mass. Capital M into x bar is equal to small m into r minus x bar. That gives us this formula for the distance of the center of mass. So with this idea in mind, let us see how we can solve this problem. Let us continue see how we can use the two formulas to solve further. Now, this gravitational force is the driving force of this system, which is passing through the center of mass between between M and M. So there is, this force cannot produce any torque about the center of mass. So angular momentum about the center of mass is conserved. Angular momentum about center of mass is conserved. So that gives us the formula. Angular momentum, we denote by L, capital L, is moment of inertia into angular velocity. Angular velocity is common for both stars. Omega is common, so I omega, and this moment of inertia I we have got for the total moment of inertia only for both masses. So which is equal to M by M plus M R square times omega, which is a constant. So this implies M plus M is already constant. For total mass there is no change, which implies M R square omega is a constant. That will be another constant, but that expression itself is constant since M plus M is constant. M plus M equals constant. So that you can take away from the result. Now centripetal force equation. Centripetal force equation. For each star, centripetal force is given by the gravitational force. You can write for either star, either for this or this, you can write the centripetal force equation. Let us say for the larger mass, Gm m by r square, separation. This is the gravitational force, which gives the centripetal force. Centripetal force is m omega square x. Capital M omega square, x bar is the radius, x bar. That is the centripetal force equation. Where for x bar I can put the earlier derived result, mr by m plus n. So x bar. So this gives us omega square r cube. All other quantities are, since m plus m is constant, g is constant, g is constant, m you can cancel, m also, this m also you can cancel. So what is left is omega square r cube. This being constant implies omega square r cube is a constant. Omega square r cube is a constant. So two important results we got. That is, this is constant, okay, equation 1. This is also constant, equation 2. So how we can use these two? Let us take note of the two results that we got. One was m r square omega equal to constant. The second one was omega square r cube is constant. Omega square r cube equal to constant. So we have to remember here in this case r changes, omega also changes in the process. Center of mass position also will change, but this quantity remains constant at all times. from here we eliminate omega, which implies mm square r power 4 omega square is constant, one constant. Then the lower one is r cube omega square is also constant. So when you divide, you get another constant, that will be mm square r equal to constant. This very simple expression we are getting in terms of the variables. Masses vary and r also varies. Where masses vary such that dm by d, capital M by dt is gamma, and this mass, extra mass is coming from the smaller star. So d small m by dt is minus gamma. So with these expressions, we differentiating with respect to time. Differentiating with respect to time. With respect to time. This is mm square dr by dt. We use the general formulas for differentiation. Then r times this differential of this, that is 2mm into m dm by dt plus small m capital dm by dt. For this dm by dt, this is equal to 0 because it's all thing is constant. Yeah, dm by dt is available here, and the small dm by dt is also available, plus gamma minus gamma. So this gives us 1 by r dr by, so many things we can cancel. M cancels. This r you can club with this. 1 by r dr by dt is equal to 2m minus m. 2m minus m into gamma. Into gamma by 1 by mm. This is what this expression we want, which is turning out to be equal to this, which you can, because m is much larger than, capital M is much larger than small m. So compared to this m, you can ignore this small m. So this becomes 2m gamma m into m, where m cancels. So that gives us the required ratio, this rate of change of r, 1 by r dr by dt is equal to 2 gamma by m. This is gamma, not r. Okay. So this is the answer that we want. So that answer you can take note, 2 gamma by m. M is much larger than this. We are using this also, these two given, that were part of the given data. So 2 gamma by small m. In the original question, m1, m2, two other symbols are used. This small m is according to that it is m2. So 2 gamma by m2 will be done. But in our, according to our convenient symbols, this is the answer, 2 gamma by m. I think this is the working part, that the two formulas that we derived, that we stated, those two formulas are our basis of calculation. These are the steps. So I think you understood the concept. Thank you.